Hello, welcome to 9.7. 9.7 is the last section of notes from this chapter, and it's based pretty much 100% based on things that we've done before and just need to refresh our minds. So you have a companion notes sheet. The notes yesterday and the notes today have both been done by people just from those notes in my teaching life. There are days that I've missed school and I made these like super detailed notes papers. So there are days that people in Algebra 2 have had to like read those and do the homework, even apart from a video. So the video should give you a big leg up on historically people that have done this without having a video and just did it from the paper. But I'll just read to you the paper and sort of interact with you video-wise. If you have questions, email me. We can try to get some Zoom conversations or other kind of conversations going in the future. But today we're talking about a thing called X-Intercepts. So reminders on a graph that X-intercepts are points where you would cross the X-axis. So this point right here would be an X-intercept because we're touching the X-axis, which is this one because that's the Y-axis. This is also an X-intercept because it's also touching the X-axis. We've been doing a lot of parabolas, which is the mathy name for U-shapes. Most U-shapes will have two X-intercepts. Although it's possible you could have something that just clipped the X-axis once where the vertex is on the X-axis, it might have one. Or I guess you could have a U like this that doesn't even touch the X-axis and not have any. That's possible. But likelihood is, most of the time, most parabolas are going to have two X-intercepts. Reminder that points like this, they would always be some number and then 0. This might be like 4, 0 or something. Maybe this is like -3, 0. But any point on the X-axis has an X coordinate that's a number and a Y coordinate that's 0. That's just how that has to be. We've learned on and off different days, I've mentioned that if you see Y or if you see f of x, those mean the same things. So today, when they ask you to find X-intercepts, they would expect us to know, or me to remind you, that an X-intercept has a Y of 0. Or I might have to remind you, or you remember, that f of x is the same as y, which is 0. So what we'll need to do on all the homework problems is grab either an eraser for my board or a mental eraser for your paper, and on your homework, where you see an f of x, put a 0. Every time you see an f of x, put a 0. 0, 0. So every problem would start off either y equals, or more likely f of x equals. Flipping to the right homework page, every problem in the book had f of x equals, but they could have had y if they wanted to. But we're going to make those 0 because that's what the X-intercept means. X-intercept means that the y is 0. And then what we're trying to do is basically have an Algebra 1 flashback. If I gave you an equation like this, the notes mentions the word quadratic. These are all quadratic equations, meaning that they have x squareds in them. What we've been doing since Algebra 1, when you have a quadratic equation, is get it equal to 0, which is already done for us today. And then if you can, factor. If you can't, we'll have to do an Algebra 2 quadratic formula reminder in a minute on some of these. But if you can factor, factor. So this problem, I can go x and x, different signs to make 4, but subtract the 3 when the signs are different. 4 and 1 can do that. So minus, the first sign here, minus, will take the bigger number, the 4, and that's a 1. This would lead me to an x of -1. This would lead me to an x of 4. The only new detail that makes this not really an Algebra 1-y kind of problem is they want the answers to be written as ordered pairs. Every ordered pair is reflecting a point on the x-axis. So I'd want to write this as -1, 0, and this as 4, 0. Every ordered pair, we're looking to find the first number from the ordered pair from doing math. but the second number is always 0. It has to be. If it's on the x-axis to be an x-intercept, you're guaranteed the 0. So I could go through these problems right now and guarantee myself every answer in its appearance is going to have that comma 0. There is no avoiding that part of this. Every problem is going to start with 0 in the initial space. Every problem in the answer, you're going to get a 0 for every y coordinate. This one, I factor x plus, so this is plus, we go same as that. Pair of 3's. You could write that as this when you factor, it doesn't really matter, but the only number that's going to lead you to is -3. Don't write -3 twice just because there were 2 of those factors. -3 is the only one answer. That would be a circumstance like this. The vertex is touching the x-axis, and that's the only one point that would touch the x-axis. This would be more of a picture like that, where it would have clipped the x-axis twice and had 2 answers. This one, I think I would try to factor off a 2. And I'm looking at that. And I would, in my mind, puzzle this over for a minute, but it's a dead end. If you try to do this for a while, you would reach the conclusion eventually that that is not going to be able to be factored. So we have to have a reminder of the quadratic formula, which is on the notes paper, I'm pretty sure. Check the notes paper. Yeah, it's on there. The formula is on there. So to do the quadratic formula, you could do it from the original numbers, which were bigger. I think it's better to do it from the smaller numbers. Just smaller is better in life and math. So the A is the name of the number with the x squared. There's an invisible 1 there. B is always the name of the number that's with the x. So that would be -1 for B. The C is another -1. The C is always the name of the last number that's by itself. So when I go to do the formula, I would need to do the opposite of B, which would be a +1, plus or minus a root. The B needs to be squared as a 1, minus 4 times A times C. Since C is a negative, there's a little minus makes plus action going there. 4 times this is 12. All on top of 2 times A. 2 times A is 6. When we did these in chapter 8, we would want to clean up that. 1 plus 12 is 13. And on this one, that's all you could really do. If this was like the root of 25, you'd want to make it 5. Like this is still alive and well. The square root of 25 is 5. Or if we did encounter something here like root 20, root 20, 4 could help us, because 4 goes in 5 times. That would be 2 root 5. We would do those kind of things if they presented themselves. But here, I'm fine with 1 plus minus root 13 on top of 6. Throw that in an ordered pair with a comma 0. That is 2 answers, because the plus or minus is a like dual identity. And then for this last one, we could try to do this again for a while. But with this as a plus, these would have to be the same as that. And there's no way you're going to multiply to 4 but add to 3. Factoring will be a dead end on that. So if factoring dead ends, we have to work the quadratic formula. There's an invisible 1 that's the A. There's a -3 that's the B. And C is a +4. So we go the opposite of B, plus or minus root. B squared, any square is a positive, so that's 9, minus 4 times A times C is 16, all on top of 2 times A is 2. We always clean that up first, and we'd be rooting a negative. Rooting a negative, people for most of your life told you a partial truth and said you couldn't do that. what we discovered in chapter 7. We could do that, it just took imaginary numbers. We are not today going to do imaginary numbers. Imaginary numbers and graphing do not mix. You cannot graph an imaginary number on an x and y axis in a normal sense. So this actually has no answer. That's your best news possible, I think, is if you try to do the quadratic formula and under the root you get a negative, you can just get out of there. There's not an answer. This would be a picture where if we did try to graph it, it wouldn't touch the x-axis, taking a stroll back to the left. The background picture for that one would be something like this. This has no x-intercepts because it's never going to touch the x-axis. It started too high and it rose forever. Or maybe it's one like this, that it started too low and got flipped and fell forever. There are pictures like this that would never have x-intercepts. Well, that's the lesson. I think that's all of the examples from the notes. Yes, it is. So basic scheme again is copy the quadratic x squared x number part of the problems. They're all going to equal 0 to be touching the x-axis. Factor if you can to get numbers. Every once in a while you might only get a single number. If factoring fails you, try the quadratic. You might even want to do the under the root part of the quadratic first, because on this, the 2 and the 3, we don't even really need those. 9 minus 16 blew the problem to smithereens to get us a no answer. Maybe start there to save yourself some time. But I's are not going to happen. But there are some rooty ones that will work and be okay as long as the roots are positive. But, upcoming days, we're at 409 homework today. There's 15 of them. The day after that will be designed to answer homework questions, which I can only answer if you ask them. So if you have homework questions, email me. We'll set up a session and a time to talk and interact on homework questions through Zoom or some other means. And then there will be a sheet coming up sometime. That's sort of just where we are. The chapter's over. We just need to figure out a way for you to initiate some conversations with me or take me up on my opportunities to join Zoom sessions to work out some help on these answers. If you've got it, you've got it. That's great. If you don't have it, you're going to need to be proactive here and try to get in some communication with me or somebody who does have this. So, see ya.